That looks good. So we're going to get started here. Welcome everyone to another fantastic webinar series here. This is the Ventilation Resiliency series. And a resilient ventilation system is one that's operating at good energy performance, as well as it's operating in the way that it's either initially set up to do or is expected to do in order to be running efficiently. The first in this series is air testing. And it's usually a fun topic. This is looking at air testing and balancing results for ventilation systems, and just some of the strange numbers that pop out, leading to even more strange things happening in the systems that point towards corrections should be made so these systems are running efficiently. As we know, ventilation systems are all mostly behind ductwork and walls and huge fan systems, so we can't always tell what's happening. It's not always visible. But the data in the air testing results will point towards those issues. So a few housekeeping items. First, your hosts, myself, Michael Pagel, Program Manager of Greening Healthcare. And with me as always is Ian and Amity. We encourage questions throughout the whole webinar. Just use the Q&A option below. This also gives us a chance to follow up on any questions that we can't webinar or don't get a chance to reach in time. And our sponsors, Enbridge and Thermogenic Boilers, our first industry member, and we're excited to have them on board for this trip for this year. And with that, I think I'll pass it on to Ian, the Executive Director of the Climate Challenge Network, to get started.
Good, thank you, Michael. And yeah, really happy to have Thermogenics on board working on the technical program for the year, as well as helping everybody with funding support. And yes, we're beginning a series, a webinar series, and I'll cover what the 5 elements are that we want to handle around air handling systems, ventilation, resiliency. We'll get a bit deeper into that as today works along. So the plan today is we see a lot happening on the whole federal, provincial infrastructure, economic recovery, carbon tax. It's just a lot happening there that we think has significant economic considerations for all hospitals everywhere in the country. So we'll run through how we see that, if you like, the world that we live in, how we see that unfolding at the moment and expect to over the balance of this year. Then, as requested a number of times, we want to kind of drill a lot deeper into specific areas. As a few folks have mentioned in the past, that sometimes we cover subjects in a way that they can't quite grasp. What exactly am I supposed to do next? So this first session on ventilation resiliency is intended to give you specific measures and things that you can do. And as is always appreciated, we have a panel of hospitals and industry player that can provide coaching on real life examples of how these things take place. So the 4 kind of key areas around ventilation resiliency for this air testing piece. Where do you start? How do you choose the systems that you should be focusing on first, if indeed you don't have a systematic approach to air testing in place already? How do you then plan the work? Because it's not just getting the testing done, which has budgetary issues, but also time to analyze the results and actually do something with them. So planning the work so that it's manageable and it works forward and engages the right people on your teams. How do you procure qualified contractors? And we've put a fair number of examples together on how do you actually read test report results, summarize them, figure out the stories they're trying to tell you, and what is the action that arises from that. So that is the lion's share of our agenda for today. Finally, I just want to give you an update on how Greening Healthcare for 2021, how the program content is evolving. And you'll find that matches very nicely with the market update, with how we see the world unfolding around us. So how is Greening Healthcare responding to what we're seeing as your realities over the next year or two, and what are the events you can look forward to that hopefully will make life easier for you and help you, again, adjust, adapt to the new normal, whatever that is, as it begins to unfold. So that's our agenda. As Michael said, please do throw your questions out there anytime. Use the Q&A, because that way we can record them, follow up afterwards. The chat disappears as soon as the webinar is over. So use the Q&A option there, put your questions out. Michael will be following those, and he will slide them in the appropriate points in the agenda. And as always, we'll appreciate your ongoing feedback and communication after this event has happened. So market update. Let's talk about a bit about the carbon tax. So the Supreme Court decision that you would all have heard about. I guess both of our provinces, we've got a number of people from Alberta, a number of people from Ontario on this call. They were the two provinces that were challenging the constitutionality of the carbon tax, and 6 out of 9 justices opined that the carbon tax is constitutional. The way they did it, the language is worth reading as to why it's constitutional, because there's some messaging in there about just how darned important the whole climate change agenda is. And as we've said a number of times, it will be coming back long after, we can't remember whether it was COVID-19 or COVID-17 or whatever the number was. The climate issue is going to be with us for the next 30 years. Carbon tax legality fundamentally changes that dynamic, that you'll hear the sound of taxes being collected on high carbon activities like gasoline and natural gas for heating buildings and homes, and that money being channeled back, as is required by law, through the Climate Action Incentive Fund to individual taxpayers. So everybody sees that credit, at least in Ontario and Alberta, the provinces that don't have their own carbon tax in place right now. Everybody sees that credit on their income taxes, and we're in that season right now. So that's a warmer, fuzzy feeling, and a significant share of that funding going back, particularly to public sector organizations, to pay for capital improvements to buildings to help reduce greenhouse gas emissions. So the Ontario school sector has seen its first $70 million, 70, from that fund already to pay for energy efficiency, carbon reduction projects within K-12 schools. And if you look at the federal website, you'll see clearly that municipalities and hospitals and colleges and universities will not be far behind. So this whole carbon tax scenario is both going to be adding pressure on operating budgets and at the same time providing much needed capital funding to allow facilities to upgrade themselves to work towards the low carbon future, which is now only 29 years away. We're committed to net zero by 2050. So that dynamic we see as a profound shift in the way the world is going to be working over that period of time. And if we kind of play out the after effects of COVID, all of that money the government spend is going to have to be repaid. So we can expect ongoing pressure on operating budgets, but we can expect a bonanza of green infrastructure funding, of economic recovery funding, of carbon tax, the Climate Action Incentive Fund funding coming into fund capital projects. So you'll see at the end of this, Greening Healthcare is preoccupied with capturing the relatively low-cost operational improvements that can help take the strain off your operating budgets, while at the same time making sure everybody is ready for the capital projects. You've got the shovel-ready projects ready to go that will have a significant impact on greenhouse gas emissions and will be eligible for what we expect to be a bonanza of capital funding over the next 2 years. So those are, for us, the biggest part of the current, if you like, economic picture around emissions and energy efficiency. Meanwhile, in Ontario, the new frameworks are either in play or being finalized for both CDM, which is electrical conservation, and DSM, which is gas conservation. And you'll see within that a real increased focus on the idea of pay for performance, that the savings measured at the meter are the ones that that can be recognized through pay for performance programs, and whether that comes through operational improvements or retrofits, whatever that is, it pays per kilowatt hour. So the final little table there Michael's put together is, if we just look at the Ontario hospitals, and interested to chat with Alberta Health about equivalent programs that will emerge within Alberta, but the current targeted savings as of 2020 is around 55.5 million kilowatt hours, and at over 3 years at 4 cents a year, the energy performance program of the ISO is introducing and working with now, that's about another $6.7 million of funding available to go towards improving efficiency, the equivalent of 20 cents on the natural gas framework. There's about 20 million cubic meters of gas annually to be saved. There's another 4 million there. So I think the messaging is, it seems there will be a good deal of capital funding available to help transition hospitals to what is essential for the low carbon future. And meanwhile, the operating budget pressures will be coming at the other end and making it more cost effective to do gas savings and emissions reduction projects, and to help renew infrastructure. And we just got to be prepared with projects and have enough lead time that we can do the right projects and not just try to respond to spending money. So again, happy for any feedback on this through the Q&A, if and to pick up this, because I think this environment is important for everybody on this call. It's the world that we're going to be operating in for at least the next 2 years. So that's where we see the market situation, and that's what greening healthcare is adjusting to at this point. So within that, the biggest area of utility cost savings, natural gas and electricity, is within, as we've said many times, within the air handling systems within hospitals. The extra pressure that's come around ventilation systems with the new world, the new reality of COVID, is for every hospital to be able to provide assurance to all stakeholders that air handling systems are safe and healthy. And bringing those things together, they can be at odds with each other, but we're looking at what we think are considerable win-win opportunities, where we can upgrade air handling systems to make them safer and healthier, and still achieve substantial reductions in utility costs and greenhouse gas emissions. And that, as is defined here, is essentially what ventilation resiliency, the way that greening healthcare is using the term, is all about. So providing the required indoor environmental quality, and we know what those standards are, and we can expect them to evolve over time. Providing those at the least operating cost, because that's going to be increasingly important. The operating budget pressures will be there, and at the least greenhouse gas emissions. And the resiliency part also implies that we can adapt readily over time. So as the world unfolds and new crises come along, new situations come along, new knowledge emerges, new understanding comes into play, that systems are readily adaptable. They can be adapted through software and programming, not through having to get back in and make big physical changes. So the intent is, through ventilation resiliency, you'll have systems that you can adjust as you go along and have confidence that they're doing what they should. As this series, as Michael referred to it, as this series unfolds, the 5 areas we plan to address, and we'll be looking, as always, for feedback from all member hospitals on your priorities. Today, we're going to talk about system testing. How do you do it? How do you prioritize it? What do you do with the results coming out of it? What adjustments, what changes do you make? The second big one is around controls and monitoring. What additional air quality monitoring should you perhaps have in place? How do you program your systems to maintain the required standards of indoor air quality metrics? How do you program systems so that you've got the right amount of outside air when you need it, but not when you don't, so that you're resetting supply temperatures. So you're putting all those smart control strategies in place that allow you to meet the ventilation, the outside air requirements, but make significant reductions in your utility costs at the same time. We don't see these things as being at odds with each other. They both require upgrading of air handling systems. Item 3, we're going to come back into all the famous retrofits, variable frequency drives, zone dampers that allow scheduling the spaces. So that whole section about what are the things that make sense now, and we'll relate those to what kind of incentives are available and what kind of industry players are out there to help make that come together. Somewhere around the whole launch of the new hospital performance report, the P3 hospital performance report, which is planned for September, we'll get into the design standards and metrics that the design teams for the hospitals in the pipeline, the P3 or other new construction hospitals in the pipeline, what are the system level metrics that they should be writing into their specifications and their requirements of their consultants and their commissioning agents to ensure that those hospitals are as efficient as they can be from the get-go. And finally, again, with a lot of feedback, we want to talk quite a bit about maintenance. How do dirty fan wheels behave? How damaging is it if you've got leaks in your ductwork or leaks in the flexible connections? How do you clean coils? How do you know if the pressure drop across a coil is enough that the coil has to be replaced, or if it can just be cleaned? So what is that whole checklist of maintenance activities that you can run through on a systematic, regular basis to ensure that the air handling systems are at their best? And then how do you document all of that so that when you have a big renovation, for example, which we may touch on with Simba from North York General a bit later, you have a big renovation going on and you want to tap into existing air handling systems, or you need the drawings that you have right now. How do you upgrade the overall level of documentation around air handling systems so that you're ready for all those eventualities over time? So these are the 5 elements. We see them as kind of a hub and spoke type of arrangement, and that all 5 of these are interconnected. They're all interrelated. So it's not going to be do 1, 2, 3, 4, 5. We'll show how they all interact with each other, and how, for example, we'll talk today a bit about what kind of maintenance should you plan for prior to testing, so that when the testing contractor comes in, they're working off a well-performing system and not simply testing a system that needs some tender loving care to get it to where it needs to be. So this is a heads up. This is our plan for Ventilation Resiliency, the webinar series that will be unfolding over the next year or so. So when we do air testing, what is the framework? What are the goals? What are the objectives? What are we trying to what's the point that we would like everybody to get to after this webinar? What is the action we'd like you to take? So one is a regular testing schedule around all material, like all significant supply, return, and exhaust fans. So when they've been measured, and not just at the airflow level, but at the static pressure level, at the observation level, at the inspection level, that you can with confidence know what your overall airflows are and what kind of air change rates you have throughout the hospital. You can speak to that with confidence because it's been measured, and the converse applies, that if you haven't had your systems tested recently, there is no way that you can speak with confidence that you're meeting the standards that are required. So the starting point is, have we got the right amount of air? The second point is the whole building pressurization, and we'll show you some interesting examples where if your supply volume is down and your return volume and exhaust value stay the same, guess what? The building goes negative, and that's where you get the howling drafts at the front, at the main entrance, And the converse can apply as well. You end up with the building being overpressurized, which is very expensive from a utility cost standpoint, but also is equally unpredictable and uncomfortable for users. Then once you got the whole building under the right pressure, the relative pressurization of adjacent spaces, so you have the right positive negatives throughout, that is a necessary outcome to, again, provide assurance that that is the case. Coming out of your testing work, we'll talk a lot about static pressure losses within the system and what they're trying to tell you and how you can make improvements that can lead to dramatic electricity savings. You know, that's where fan power is the biggest electricity user, I think, in every one of your hospitals. And getting after static pressure can actually allow you to provide greater airflows, but at significantly lower fan power, which is the big reductions. And we'll talk a lot about what are the metrics of indoor air quality that you could and should be tracking and reporting on, so that everybody, again, has the comfort and the confidence that the building is healthy and safe, which is what it has to be. So first part is the testing and what comes out of that. Then the second part of the goals that we have here is, what do you then actually do? What are the changes you can make that improve health, safety, and comfort? And what are the changes you can make that ensure that you're meeting the air change rates you require, but you're still making significant reductions in energy and greenhouse gas emissions? So again, this is the big picture of where greening healthcare is trying to get to in terms of goals. And we're going to give you a whole bunch of examples and feedstock today, and hopefully we have a little poll at the end. You'll tell us, after seeing all of this, where, if anywhere, you think that greening healthcare can help you move forward with, again, a systematic, strategic approach to air testing. West Park, this is, if any of you are old enough and been around long enough, this is probably from at least 5, maybe 6 years ago, the project that West Park took on, John Federico and his colleagues. And this was air testing of a number of their chassis systems. You'll recall that West Park is about to be, the old hospital, which is where these systems are, is about to be demolished. The new one is rising out of the ground as we speak. And I'm just going to go to the thumbnail here so that I can see the whole picture. And this is a typical report that you can expect to get back from a testing contractor. You get a table, these are extracts from it. You get a table of numbers, which typically are specified at the design stage and what they're actually running at. And then you get a nice picture that lays it all out kind of graphically. And at first glance, there's nothing, it's really hard to look at that and say, oh yeah, man, look at that's happening there. And you will, if you're not already there, you will become increasingly skilled at looking at these reports and seeing the anomalies, as Michael said, the unexpected things that arise, and importantly, what those things mean and where you go from there. So in this case, just to make it a bit more readable, we've just colored in test scenario 1, which is the 100% outside air test. So this is a recirculating system. You can see the recirculation air and the exhaust air, the recirc going down, the exhaust air going up. So these would always be tested at 100% air, which is the free cooling mode, which is a relatively short period of time in this climate. And also in the minimum outside air, which is how the systems would run right through the hot weather in the summer and right through the cold weather in the winter. So you measure in those two scenarios because they tell you quite different and complementary things. When we look at the 100% outside air scenario here, there's a few things. One is that the total airflow is 23,351, and sorry, on the supply side versus the 38,000 it should have been. So this is one of those that we'll talk about through today that has deteriorated over time. And the return air fan at the same time is running at 22,201. So it's also down significantly. What matters just as much is how different that is during both the 100% outside air relative to design. So the design says that we were looking for 8,000 CFM more supply than return to ensure we have adequate pressurization. During 100% outside air, we're down to only 1,000. And during minimum outside air, once again, we're at 27,000 return, 24,000. The return air there, in fact, is a little higher. And guess what? This is one of the hospitals that had negative pressure in the front lobby. And one of the solutions to this was to slow the return fans down further to maintain that differential between supply and return. Again, without belaboring these things, because we're going to ask you at the end how much more information would you like on this kind of interpretation stuff. But when we have the return fan at 100% outside air delivering at the top, there you'll see plus 1.07 inches. And somewhere between that and the intake plenum in the bottom right-hand corner at 0.71, at minus 0.71, there's a real problem here on the recirculation damper, and indeed we found that it was rusted largely shut. So the return fan's working really hard to get the recirculation running through. And also when you're at 100% outside air, that minus 0.71 inches, if you're following me on the intake plenum, that's connected directly to the outside air. That's a big negative pressure. And sure enough, that air intake was plugged with debris and probably a bird's nest or two, and that was easy to clean and fix. So the purpose of this little story is just one example of one system in an older facility and a few of the things. Then we could run through the same thing on the minimum outside air. A few of the things that when you get these things done and they're done by a capable contractor and you read the results, they lead directly to typically maintenance action and control adjustment actions that can resolve comfort problems as well as significantly lowering energy use. So there's West Park. Here's another golden oldie. Archie, I think you're on the call today from Runnymede. This is from a previous presentation, a previous case study that was done. And once again, when you summarize, this is a relatively small facility. When you summarize all of this, you see that the design airflow was supposed to be 123,000 of supply, but for a whole bunch of over-design reasons was running at 156,624. The return exhaust, when you added those together, measured them and added them together, was a lot less than it should be. So the overall net supply, the pressurization of the building was way higher than it should be. Again, at an excessive utility cost and significant effects in terms of comfort around all doors and exits and areas which were connected directly to the outside. So just two illustrations, and again with a technical panel, we're very interested to get more into real examples of how this how you go about putting in place a strategic approach to measuring these things. The most strategic approach we've seen so far comes from Alberta Health Services, where I think we've mentioned before, Harry and his team went through their utility management plan a little over a year ago, and now identifying their high potential opportunities and putting in place a program which predictably has air testing and controls and recommissioning adjustments. And let me just ask Amandeep, who's been working with AHS on these things, to pick up 3 examples coming out of there. And then I'm hoping that you have enough examples to go on and we can get more into the nuts and bolts of how you actually go about dealing with this stuff. So tell us the story out of this one, if you would, Amandeep.
Thanks, Ian. Yeah, so this is sort of an interesting story. This represents the 2 air handling systems with their respective exhaust fans and their return fans. So they're serving the patient care tower 2nd to the 6th floor. So originally the design, so we put both the liter per second and CFM. So the original design on the supply side for AS1 and AS2 was around 38 to 45,000. But when they measured the actual flows on both of the system on the supply is actually running higher. It's around 50,000 to 54,000. And similarly on the return side, they were designed for 22,000. They're running at a lower around 18,000. And the exhaust is actually, one of the exhaust fans, the EF22, was designed as 10,000 CFM, is actually running backwards. So when you add them together, the original design was around, need to be net positive around 6,800 CFM, but the system actually is running at 59,000 net CFM. So, I mean, it's given that when you ask the facility, they just come and say that, well, they had tons of pressurization issues with this building because, and what happens with that is they can't close the door. I mean, there's always been issues like that, but I think the sort of in what this example shows is that fundamentally, if you have issues in the building, it's just going to drive you to the air testing systems, especially around pressurization. And you're going to see that once the air testing results comes, there is a story hidden in it. In this case, it's kind of pretty clear that system is not performing as it was expected compared with the design.
And the result of this will be big energy savings in fan power and heating and cooling and humidification in all of the above.
Exactly, yeah. This is another example here. Simply, if you look at the highlighted red section, which is the outside air damper pressure drop. So when the system was measured with traditional air testing, it showed that 0.99 inches or almost a 1 inch of pressure drop across the outside air damper. And similarly, the cooling coil was around 2 inches of pressure drop. So this is sort of a very straightforward process in the air testing where you request your tap contractor to come in, do these pressure drop across the component, and it tells you a story in its own that why the system is not performing as it's expected to perform. And the majority of the time, the things like these, when you have outside air damper pressure drop, when you expect it is around 0.1 and you're seeing a 1 inch, it tells you that there is an issue with that, whether it's a struck damper or whether it's a louver needs to be clean or the mesh needs to be clean in these cases. The third example is another interesting one, is where your sort of return fan is not working as expected and the supply fan still needs to get all the air. So in this case, what it's doing is that a supply fan was pulling the air through the exhaust relief. So basically, none of the exhaust air or none of the air from the return system is exhausted. And in fact, the makeup air that's needed by the supply fan is being made through the exhaust relief berm. And it's kind of, you can see it's sort of related because your outside air damper in this scenario is again at the higher pressure drop around 0.84 inches. So the air sees the least path resistance is through the relief duct rather than through the outside air damper. So system is making up that air through that relief duct rather than through the outside air damper. So this is sort of like, it leads to additional problem and you're not able to maintain your system or pressurization in the building is because these fundamental issues within the system haven't been resolved.
And we're reminded, Amandeep, of the power of a fan. You know, anybody who's opened the access door on the suction side of a fan knows very well those things are beasts. They will not be denied. So if the supply fan is looking for more air than the return air fan is bringing back, it doesn't matter what you set your minimum outside air setting at. You know, those numbers are completely meaningless because it's going to get that air from somewhere. If it's not coming back through the system, it's coming either from the outside air or the relief air intake damper, because it will not be denied. That supply air volume will be satisfied. So
exactly that. Yeah, the amount of outside you bring into the system is directly dependent on your return fan and the supply fan. So if you don't have the right differential, regardless of the damper position, it's going to bring that amount of outside air anyways into the building.
Perfect. So we look forward to working with Harry because we believe a number of hospitals are proceeding with this type of work at the same time in Alberta, and we think there are going to be some really rich case study stories to share as this picture unfolds, and that what is being done there is directly applicable to the kinds of things that we have to be addressing in Ontario and in fact across Canada and across North America. So again, the story so far is looking to illustrate that this stuff matters, that if you're not doing things as frequently as you might or as strategically as you might right now, that is one area that you should be looking to improve, both for health and safety and for energy reasons, and that our intention is to bring you useful templates and approaches and methodologies that can help make that work easier for you on a go-forward basis. And as always, we're delighted when some of the leaders that we're aware of, sometimes we're not aware of, and we'd love to hear from you. If you're doing some really progressive things on this front, please do let us know. But some of the leaders we're aware of, when you're willing to share your time and your expertise, and sometimes even your specification templates with everybody, that really moves things forward. So today, Amandeep is joined with Harry from Alberta Health Services, who we've heard from before, and Andrew Blair from Sinai Health System, who is doing all this stuff in the context of one of the more massive existing infrastructure and your projects that we've ever seen. Simba, who's working through this at North York General Hospital with big renovation going on, but also, once again, an aging hospital with work. And we're really happy to have Matt Crittenden from Air and Water Precision Balancing, who works with both Simba and Andrew on these kind of activities to bring his particular insights. So welcome to these panelists. And again, a great appreciation for your generosity in sharing your time and your expertise. And what we really want to go through with you today, and just remind everybody, this webinar is recorded. You'll be able to access it on the Greening Healthcare website after this event. So if there are bits of it that you want to kind of revisit, that's great. But these are the 4 areas we want to get through. How do you get started? Like if you're not doing this and you've got a big hospital, it was nice seeing the 5 air handling systems. I think it was at Runnymede, but many of you got 50 air handling systems. How do you prioritize? How do you get started with those? How do you procure the work? What's the scope of the work? What does the actual physical testing look like? What are the kind of things that you should be considering doing before you bring the testing contractor in, so that they're testing well-working systems? And the last piece there, analysis and action, I want to spend most of the time, which is, hey guys, once you've got that information, who does what with it to turn it into action that can make improvements? So let me, if I may, start with you, Amandeep. When you're talking to a new hospital member of Greening Healthcare or a hospital client for Enolife, where do you begin? If you've got 25 big air handling systems, do you do them all at once, or do you just run out of then capacity to do anything with all the data coming in? How do you choose the high priority systems?
I think, I mean, with healthcare facilities, we know the highest priority has been given to address the IPAC needs within that facility, and it's sort of given, like, I mean, the 2 things that I sort of see as the most important with hospital is one is the IPAC needs. Second thing is making sure the pressurization, which is part of the IPAC, pressurization within the department or overall building is maintained. So if you have the opportunity and you haven't done the testing for a lot of these systems, so my recommendation would be to start working with the critical systems around, like operating rooms, for example. If you haven't tested those for air change rates in a while, so that's probably the starting point. And then also focusing on resolving if you have an existing pressurization issues within a department or within a multiple floors that you've noticed over the years that haven't gone over the time. So addressing those systems as a first priority, because that's going to give you buy-in from the IPAC as well as the facility side. You will have better comfort. Once you improve the comfort and meet the code requirements, the energy efficiency comes along with it. So as soon as you fix those systems, you're definitely going to save energy efficiency, and then you can sort of focus on those aspects of energy efficiency and making sure the systems are working as intended.
Okay, and Andrew, you had a pretty systematic approach going at North York General. When you got to, especially Mount Sinai Hospital, with everything going on there, how did you go about kind of planning, like where to begin?
So I took a 3-pronged approach because I see it as a team. you guys have shown a lot of information, and there's a lot of ways to review the information. But if you don't have all the right technical expertise at your disposal, it's really hard to know what to do next. So as soon as I got in 2018 to Mount Sinai, I wanted to be able to set a baseline and pull the team together. So I created 3 RFPs right away. One was for air and water balancing, to have somebody on my team that I could work with on creating the annual and the monthly reports that I wanted. Also, as you saw, you're looking at BAS graphics and ensuring that what you're looking at on the screen actually is indicative of the actual physical systems and how they're operating is key. You're never going to win if those systems aren't reading the right information. And so making sure you have a robust BAS contract in place, you create that partnership, and you invest in the constant maintenance of those systems. You're unforgiving on question marks on the system. It must be solved. It must be replaced, so that you can continue to optimize and create efficiencies in how you're delivering. And then, as you'll find, you always have to try to get back to what was the original intent of the system, and interpreting both what the air balancers are reading and sending you as snapshots in time, and what the BAS is reading and telling you as live and moving data, bringing on a mechanical engineering partner, somebody that you can, over a multiple year journey, you can go through and systematically optimize the system and create the schematics for what the whole building is doing. So I had to pull the 3 prongs together so that I could start to really get a good picture of what was happening, because the phase 3A project that you alluded to that we're undertaking is 150 phases, a third of the building, some new, lots of integration with the old, and a lot of the design was off the premise of a nameplate. And that definitely wasn't what you would find when you started to connect to, new system loads into the old building loads. And so we really needed to dig in and have baseline information in order to make this project continue to move and satisfy the new space demands.
That's extremely helpful. Getting on to procurement. So once we decided we need to do this, and Harry, maybe I could pick up with you. You always have had, and you're getting a lot of air testing work done. What, if any, issues are you finding around? Do you have the documentation that a testing contractor needs to get their work done? Have you got a well-defined scope of work, and how frequently do we think that testing should be done? And I'd like to move on to Matt and say, from the contractor standpoint, what do you think owners are missing in terms of how they specify the work that they're asking you to do? But Harry, how do you procure this stuff?
Well, with us, we have very set procurement rules. So and unfortunately, and it's based on value of the contract, but because getting the testing done is actually really a low cost of your overall project cost, that you're essentially buying labor. We don't seem to have too much of a problem with that. And then, so once we go to a site, a lot of our sites are outside of the main area. We're provincial. And so when we do sites that are away from the 2 main centers in Alberta, Calgary and Edmonton, we find sometimes the quality of the balancing contractors is not quite as robust. So we prefer to hire out of the main centers. So if we're going to have somebody get into a vehicle and drive or fly, we would like them to do the entire facility.
Okay. And frequency, when you do you do this on a as needed basis, or do you have a set frequency for how often retesting should happen?
Well, we have over 100 acute hospitals in the province, so I'd be happy if I can make it through once before I retire.
Okay, that's a good answer. And Matt, from your perspective, you see a lot of requests for quotes and so on from different hospital owners. What should they know or do differently to get the job that they're really looking for?
Well, fortunately, I work with some really good clients already that already understand the value of air balancing. So when they get a quote from me, it's usually, they know it's going to be fairly priced. That's on the service side of things. On the new construction, that's a whole different story. Unless I'm spec'd with other reputable companies, I probably won't even quote a job, because there's a lot of balancers out there that are focused more on speeding through the project, getting the report pushed out to the contractor, because the contractor wants to close the job. The way I do it is I'm working for the owner, so I want to make sure the contractor's doing a proper, the installation is going well, the commissioning is going well, and we get our results that we need. So that always comes with a price, but in the long term, it always pays itself back, because to Andrew's situation right now, he's called us in and we're valuing the systems, and what's there on paper is not necessarily there in reality. And so now we have to sort of we have to figure out now, where did things sort of fall off the tracks. And now we have to do some investigative work, auditing, going through records. So it costs a lot more money to do it down the road than up front. If you get a good contractor team in when you're doing your design build, the duct there will be minimal duct leakage. That is a huge loss to the owner. And it's a nightmare for the balancer to try to understand why the fan is doing what's doing, but you're not getting the results down at the room level. And so the jobs that we are doing in a new construction field are usually very targeted and very specialized in the healthcare facility, because those places do understand the value of air balancing. And I would say that owners need to make sure that they're picking a balancer that's certified with a reputable organization. And there's about 2 in Canada that I can vouch for. And that's the AABC, or the Canadian chapter, which is the CABC, or NEBB. If that's a starting point for any owner to work with. And also too, when it comes to using a balancer, the trust is really important as well. So usually, most of my business is word of mouth, because I'm helping out one customer, and then, you know, the health community is very small. They start talking and they realize, okay, I might want to have a second set of eyes on this project. So that's how I get my work. Quoting is, to me, coming back to your question, it's an RFP, so it goes out to the public, and people have an opportunity to price it.
Right. So what I'm picking up so far from you and from Andrew is that getting from one end to another, as you say, is a lifetime's work. So the idea of systematic, strategic prioritization and multi-year relationships and having a team in place. So typically what we're hearing is multi-year contracts for this kind of work, not 1 year and then go back for the next project and so on. So the idea of this continuity to this is important. Simba, let's move on to you. For physical testing, you're getting this kind of work done for different reasons all of the time. Who's involved in that work, and how do your staff interact with the testing contractor? Is the work that you like to see done to get, if you like, to prep the air handling system before the testing contractor comes in? And maybe just to add to that, do you have maintenance checklists in place of the things that you have your guys look at with different air handling units on a regular basis, like air leakage, like dirt buildup, like clean coils, all that kind of good stuff? How do you manage all of that?
Well, we have, internally with our own staff, we have a computerized maintenance management system where we're putting quarterly tasks and semi-annually tasks with our own team, which is inspecting the unit and verifying that the unit is clean, the filters are clean, the coils are clean, and so forth. And then, as you alluded that Andrew was here at Northrop General prior, I mean, they built a fantastic relationship with the three areas, with the partnership with Matt and the engineering team and so forth. So we have a systematic trend now that we can go back and verify. So when we have a renovation project, we have to figure out, do we have enough CFM and so forth? So we engage Matt's group, and we'd like to see where we're heading towards with the ability of the fan unit to supply what we need to supply, and we're hitting the numbers when we need to hit the numbers. And we had a renovation project where we had a fan unit that was off by I think 25,000. No, sorry, maybe 20,000 CFM or something like that on one of our units. It was a unit that was installed many years ago, and we now wanted to take that capacity and add it to a new area that we're developing. And we took it on, and we put a robot in there, and Matt helped us out as well to find out where the leakages are and so forth, and allowed us to hit the commissioning numbers prior. So we try and get this stuff done prior at the early stages of the renovation project. So that way you can get all your RFP documentation in place. And then when you're at the end of the project, it allows the commission to happen smoothly.
So that's very helpful. And we've actually got the AHU9 curve, if we have any time to for you and Matt to chat about that in just a second. But that's right. So that whole space where you've got a major renovation and within the hospital, and there's always the reality that you're going to be most of the time tapping into existing air handling systems, and if you don't know how they're running now, it's very hard to know if you've got the capacity and if you have the right conditions to run those. And I guess you're seeing that in spades right now, Simba.
Yeah, absolutely, right? We want to find out if we're tapping into this unit, how well is it performing? Do we have capacity on it? And where are we on the fan curve? And why aren't we on the curve? Why are we off the curve? And what's the resulting factor? So these are all the things that we need to look at, so that way we're maximizing and optimizing our air handling units.
Okay, so it would be interesting. So the analysis and action, that's where it all comes, right? Eventually you've done testing, and if over time you've got most of the hospital covered, what do you do with that information? So we provided some examples before, so I'm thinking we've really given Amandeep a chance to talk about some of the things. How do you read the test reports, find the improvements? We've covered that. And Simba, don't want to put you on the spot, but how is it within the CMMS? How do you track over time? And Matt, I welcome your thoughts, how the building systems are changing over time. So if you do testing, for example, every year or every 6 months, is there a way of tracking where it was 6 months ago and where it was 2 years ago? Are you able to see the deterioration over time? Or because very often Amandeep will report on going into a hospital and things are just crazy. The supply fan's 50% higher than it should be, the return, but it got there over time. So I'm wondering, when you have regular testing like this in place, is there a means of tracking how those systems change, how they evolve over time?
So we're very fortunate. Like, we have Matt's group in. He comes monthly here to do our pressurization testing, and then we have him come in and do the semi-annual and annual inspections on the air handling units. And his air handling units, there's reports on there, right, that allow us to understand where we are against design, and there's notes there. And because Matt has some history here and he's participating in the projects, there's notes in there that tell us the reason why our numbers are changing and so forth. So we carry on the notes, and we have the history there. So we track that. And then as well with the CMMS, we have both our staff and our contractors as well engaged in the CMMS system. So then we would engage Matt, or we'll do a follow-up to find out what's going on with the air handling units as well.
And maybe back to Andrew briefly on this one, the building condition assessment. How much involvement does the engineer doing your building condition assessment? Do they pore over the test results that you've got? Are those helping inform their recommendations on what should be replaced or renewed?
So it depends on what level of, so if we're talking about the ministry overarching building, if anybody's had them in, they're only as good as the work you put into them and the time you give up in order to take them around to systems. So you literally have to spoon feed them the information so that they write reports based on that. Because again, they've got X amount of time to be on your site, and they've got to walk through a ton of space. So no one will know your building as well as you do, depending on how long you've been in your building. And so the Dean report, used to be the VFA report, is only as good as the time investment you're going to put into telling them about all your problems. If you don't tell them, they don't find it, you don't get the dollars to replace it. So I've here invested, I was fortunate that they literally were coming to site when I started, and we invested a ton of time, which then translated into a huge increase in annual ministry dollars to replace systems, far more significant than this place had seen for many, many years. So it's been a great investment of that time for me and for the hospital, because we've been able to do some significant retrofitting since I've been here.
That's a very nice addition to this whole thing. So this whole idea of being prepared, if you haven't done test reports, you don't have the input information to be able to have that intelligent conversation with whoever's doing the building condition assessment, and funding does flow out of that. So panel, thank you. Let me just spend a second on this with, because then we have a poll, because this is the end of talking about what people need to be doing now. We need to hear from people on where, if anywhere, they would like to see some help. But this is AHU 9, as I threatened you with some along the way. So this is a system that the hospital's looking to connect into as part of a big renovation project in their emergency area. So there's 4 areas that are affected, looking to tap air in from this. If anybody on the line is not familiar with this, this is kind of one of the needs. It's one of the literacies, if you like, that everybody in your positions, I would respectfully suggest, needs to have. You see the red line there of the system curve, and you see the yellow dot at about 5.6 inches of static and 20,000 CFM. And you can see that that's what the system should be running at. What, again, over time, everybody will get familiar with is that nothing on this chart makes sense, and it needs further investigation, exactly as Simba was saying, so that you know what you're looking for. And maybe the other big example is you need lead time to be able to get this done. So if your project's getting underway and you discover this, it's too late to be able to do the kind of investigation and get the system up to snuff so it can play its role. So here, a 20,000 CFM system is only dealing 16,500 CFM. Strangely, from that, the motor amperage and the motor brake horsepower are surprisingly high for that. So we got a system here that's working really hard to deliver not very much. So the operating point you see there should be on the curve, and it's not. Could have to do with air leakage. So Matt, not sure where your guys would have tested the airflow, but if it's downstream of the unit, perhaps we're losing air from flexible connectors or holes in the ductwork from previous testing work that's been done. But let's say if you track this any which way, nothing lines up. It's using way too much, the unit's using way too much power for the amount of air it's producing. Its static pressure is low, and it's not anywhere close to the original design curve. So Simba, with this picture, if you had your druthers, what would you have done when, so that AHU 9 was ready for the project that you have in play right now?
You would, well, we'd have to investigate where the leakage is and how, if there's any buildup of debris on the blower motor or the blower, see what's going on in the unit itself. You mean we're off the curve, like the static pressure based on where we are with horsepower and so forth. We're well below the number. So there's definitely something going on with this unit. So either we've got a major leakage, or there's something wrong with the blower and it's not performing as well as it should, and it's creating a lot more power. So if we optimize this, then of course, I mean, we would be able to reduce the amp load and reduce the energy and be able to use this fan from multiple areas more than what we're using it now.
Yeah, Matt, as you look at this, anything springs to mind about what Simba, but by extension everybody else, should be thinking about these kind of older systems?
Yeah, that's just it. It's when it's an old system, there's a lot of history in between that can really throw things off. The fan blades, first of all, because of COVID-19, we're really limiting going into units when they're even when they're off. It's just our safety protocols right now. So it would be nice to get in and see that fan close up instead of these are just right now. These are dynamic testing right now. The fan's running, so we can take everything from the outside. It would be nice to get into the fan unit, stick a hose right in the fan, wheel, and then run a hose outside to the outer cabinet to get a much more accurate static pressure.
Okay.
But that being said, things should line up a lot better, even given what we've provided. What we do know is, what we can say the constant is, we know the RPM and we know the CFM. So that's the nuts and bolts right there. And also too, what's not up there, what you should also look at is the cooling coil velocity. Because even though that fan says it can do 20,000, at 20,000, that coil velocity is gonna be over 500 something feet plus. So now you're gonna maybe you got your airflow, but now you've got humidity level problems. And that's you don't want that at all in a hospital. So looking at those numbers and that fan curve, I would be the one saying I would not want to tap in any more from that unit. It's old. I don't want to take it out on the highway. I would leave it the way it is. If there's any way you can repurpose some of the air off of that system, that would be good. Look at maybe a department that is being served by HU9 that can now be tapped into a more robust system. And then that way, you could then divert more air from HU9 up to the other area, the emerge. There's just so many, because I know this system, there's so many, there's just a lot of extenuating circumstances. This fan is located in a mechanical room that's all by itself, and it's pretty much surrounded by, it's been built around by admin areas, pharmacy, IPAC's offices right next to it. And it's almost like that fan just it's being squeezed as much as it can. And the history, like I said, there's a lot going on there. To explain why the fan is derated that way, I can't. It also too, maybe the manufacturers submitted the wrong fan curve for this. It would be nice to go in and actually maybe double check that serial number off that fan.
Just very briefly, Matt, do you have a history with this fan? Like, should this have been picked up before?
Oh yeah, like that's the performance of this fan has been documented for quite a few years, but no one's ever wanted to tap into it until now. So now it's being put under a microscope. And
going back, Simba, I guess the problem right now is you haven't really got time. Construction's about to begin and there's no time to review this, or is that going to work out?
Yeah, no, we're behind the 8 ball. I mean, we looks like we may run out of time to look at this, but we're trying our best to see if we can get in front of it for even future consideration. But it looks like we are running out of time on this, okay, unfortunately.
So great examples, everybody. And again, I know every other hospital on the line is nodding and relating to these day-to-day realities and year-to-year that you guys deal with. So with this story in place, Michael will pull up a poll right now and I'll walk you through these questions. But just for the hospitals online, could you just take a moment and tell us where would help be useful to allow you to move forward with this? So Michael, how does this work now? Is the poll going to pop up on everybody's screen? Is it there already?
Sorry, I was on mute there. It should be up now. The first question is multiple choice. You can choose as many answers as you want. And then the second one's just yes or no.
So let me walk through this. And again, if you're responsible for a hospital, please write it down, because we will be using this to prioritize how we work forward from here. So in terms of getting the work done, would it be useful to have, if you like, a greening healthcare, and there's ways then of getting this done, a greening healthcare scope of work that you could use, edit, adjust to your requirements so that you can go out there and properly procure the work that needs to be done? Would it be helpful to have a list of testing contractors that have done work in member hospitals with endorsements from those from the hospitals where they feel that they've been well served? Would that be helpful to you? And again, only check the ones that are important, because we can't do everything. And so we'll try to focus on the things that matter. We've given you a dozen examples of the kind of things that you find out of test reports. Would it be helpful to have a bit of a template checklist of, when you're looking at air testing reports, check this, 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 and this, and this, so that you can do it yourself, or you can direct one of your staff or one of your service providers to do it? Or would you like to go beyond that with the idea of tutorials, where you could get, and again, we'll figure out how to make this work, you could get either with a number of hospitals together or with your staff together for your hospital, look as we are today, look at your reports online and be able to work your way through what's it telling me, what does it mean, so that people can actually make the connection between test results and action. So that's the first shoe. The second one then is, none of this is going to get fixed immediately. This is not a one-timer. This is an ongoing development process. Would you personally be interested in lending a little bit of time to be part of ongoing advice? It would be probably no more than an hour and no more than every couple of months, but getting the right group of people together to talk about this is the best way we found to come up with really practical solutions that work. So step one is, what do you need? And question two then is, are you interested in getting involved and helping with that? So if you've been able to complete your poll right now, please submit it. If not, we'll leave it open. And let me just, because I know we have time is never our friend with these things, no matter how well we think we're organized. Let me just give you an update on, Michael, do you have to take it down, or can I just go on to the final slide?
I can leave it up.
Okay, so why am I not getting why is it not moving on to the final slide for me?
Oh, maybe not. Okay, I'll end the poll here and then share the results.
Thank you, perfect.
If any members are listening to this recording in the future and you have some feedback on this, just drop me a note on what your feedback is. So we had the checklists were the top priority, tutorials second, standard scopes of work, not so much for the list of testing contractors, and then 5 people interested in being part of the advisory group.
Perfect. Perfect. You'll be hearing from us. Thank you, everybody. Again, without feedback, we are working a little bit in the dark. Final, and again, apologies for being a little bit over time. What you can look forward for the balance of this year, again, goes right back to the first slide. We talk about how we see the world unfolding with the hospital sector, both here, Ontario and Alberta, going forward. As of recently, we've decided to put on a mid-year forum on June the 23rd. And if you could mark that day, there'll be a morning session and an afternoon session. The morning session, we're talking to a number of people. We'll find somebody who can really speak with authority about what sustainability looks like in healthcare in these crazy times that we have right now. We have gone to the the public reporting database, the Ministry of Energy. We've looked at, so we actually have ranking of every, not just screening healthcare members, but all the hospitals in Alberta, in Ontario right now. We plan to merge that group with what we know, with your approval, Harry, of the Alberta hospitals, and come up with a much more definitive statement of what are the most efficient hospitals in much larger numbers. What do those look like? What makes them special, and so on. So it'll be the first time releasing a ranking of all Ontario hospitals, and we'll be reaching out not just to Alberta, but to other jurisdictions to submit their own data. We really believe it's time to start moving on a much bigger scale with kind of quantifying the potential and identifying the right opportunities. And as we've done with other forums, we will be talking to a number of knowledgeable people within senior levels of facilities as an executive panel, talking about how in these crazy times do we actually get stuff done. So June the 23rd, that will be our morning session. The afternoon session, we plan to paint the big picture of ventilation resiliency. So you saw one piece today. We'll put the big picture together, what those 5 elements look like and how they interrelate. And we'll have a substantial update around low carbon central plants, how you transition from existing steam-centered high carbon heating and cooling plants to the future of low carbon plants and how we're going to get there over the next 30 years. As mentioned, September the 15th, we'll be launching the new hospital performance report. This year, that will include an in-depth case study of Humber River Hospital. We know it's the most energy efficient acute care hospital that we've been able to find in North America. We'll be going into the sub-meter and the system level of data to document why it is as efficient as it is. So we've got specific metrics that new hospitals can design to and existing hospitals can work towards. So that whole area of design and performance metrics. And we're talking to a number of organizations about potentially sponsoring some of that work so that we can have specific system level information to share. And plan for December the 1st, that's our year-end celebration. We'll have pretty good idea of the results for this year by then. We'll be recognizing great success stories. And importantly, we'll be presenting our plan for 2022 with a clearer sense by then of what the new year holds in store. Hopefully we're on the other side of the pandemic by then. What is that going to look like? What is the economic recovery going to look like? What do we see happening with operating budgets and ongoing infrastructure funding? So these are our key events for the rest of the year. Please put them in your book right now and watch out for the announcements as they come along. And finally, as always, you know where to find us. Michael is the program manager. He gets calls every week. If you're not calling him, then other people are. So please, any questions or concerns you have, let us know. And on the technical side, anything to help understand some of the work that you're doing, Amandeep is always available to answer your calls from there. So as always, again, apologies for going over a little bit on time, but hopefully you found the content useful. We do welcome your feedback. So if you have thoughts in mind right now, as you know, we dropped the evaluation template because it wasn't being used in the way that we expected it to. But anybody who has thoughts and ideas about what you've just heard, please do drop us a line and it will affect how we plan the next event. So be well, stay safe, and we'll look forward to talking to you around this mid-year forum in June. So thanks everybody, and thanks Michael for getting all this put together. Bye now.